Okay, so section 4.5, writing a function rule. So what this section is really going to be about is real world functions that are represented by equations. So we're going to get a decent amount of real world situations, and we're going to have to represent them using equations and functions. Okay, so first up, our first problem says that you can estimate the temperature outside by counting the number of chirps of the cricket. I know it sounds weird. The outdoor temperature is about 40 degrees more than 1/4 of the number of chirps the cricket makes in 1 minute. What is the function that represents the situation? So we know in a function that there are two variables. So let's first define our variables. So our first variable is going to be T, which is the temperature. Okay? Our second variable is going to be, let's say, C, for the number of chirps per minute. Okay? So the number of chirps per minute and T, and we're going to relate these somehow. So the sentence that really is going to help us is this one. It says that the outdoor temperature is, so the temperature is, so doesn't that mean T isn't is meaning equals? Yep. Is about 40 degrees more than, 40 more means 40 plus, 40 more than, 1/4 the number of chirps. So 1/4 of all of those chirps per minute. And right there, that is our equation. That's our function. So it's all about defining our variables and using our situation to write an equation. That's about it. Oops. Okay. So next up, it says that a kennel charges $15 per day to board dogs. Upon arrival, each dog must have a flea bath that costs $12. Write a function rule for the total cost for n days in boarding plus a bath. And then it asks us how much does a 10-day stay cost. So first we're going to write our function, and then we're going to write our equation. And then we're going to figure out how much money it's going to cost for 10 days. So there's two things that are variables. It already tells us what one of them are. It says that n is the number of days that the dog is being boarded, and then we need to come up with our own. We're also talking about money, so we want to know the total cost. Okay. So total cost is usually going to be on its own, right? So our total cost equals everything that's being added up for all of those days that the dog's in the kennel. So the first line says that a kennel charges $15 per day. So 1 day is $15, 2 days is $30, 3 days is $45, and so on. So what you're really doing is you're multiplying this 15 by however many days the dog is there. So our total cost is going to be 15 times n, which is the number of days the dog is there. And then it says, upon arrival, every single dog must have a flea bath. So there's no option in that, and it's not per day. It's just one time that the dog gets this flea bath. So in addition to those $15 per day, you're adding on $12 because they're not getting that $12 bath every single day. They're only getting it one time per their stay. So this is our equation. This is our function rule. C equals 15n plus 12. So now it wants us to know how much does a 10-day stay cost. So we know that n is our variable for days, so we're going to plug in 10 for n. So I get that C equals 15 times 10 plus 12. So this gives me 15 times 10, 150, plus 12, and I end up with $162 for those 10 days. It's not 150, it's 150 plus that $12 bath, 162 days. We have one more question, and then we're done this section. So this question says, write a function rule for the area of a rectangle whose length is 5 more than its width. What is the area of the rectangle when its width is 9 feet? So we have two variables that we're looking for. It's talking about width, and it's also talking about area. So we're going to use W for width and A for area. But whenever it's something like this, I always like to draw a picture. So let's draw this picture of a rectangle. So this is my width, right? It says that my length is 5 more than its width. So I can represent my length as 5 more than the width plus 5. Now area, we know, is we multiply our length times our width. So if we want to represent this, we can say that our area equals our length times our width. So W times our length, which is W plus 5. Now, if we want to simplify this, we see our W on the outside of our parentheses, so we can distribute like normal. So W times W is W squared plus W times 5, 5W. And this is our function rule. Now, the last question it asks us is, what is the area of a rectangle when its width is 9? So when W is 9, what is A? So let's plug it in and see. So we're looking for A when W is 9. We plug in 9 for W, wherever we see W, and we simplify. So 9 squared is 9 times 9, which is 81, plus 5 times 9, which is 45, and we end up with 126. 126 what? Well, it's the area, so it has to be feet. And we always know area is squared. Okay, that's about it. So this last question talks about the area of a triangle. So it's going to be modeled after example 3, but with a triangle instead of a rectangle.